This question is about understanding how the Nystroem method, a technique for approximating kernels in machine learning, works. We'll focus on the parameter n_components. It is an important concept in dimensionality reduction. I have a dataset to work with. It contains 1,000 different data points, each described by 50 different characteristics or features. I am using a Gaussian kernel, a common type of kernel function used in machine learning models. A kernel is a function that measures similarity between data points. The Gaussian kernel uses a Gaussian function to define this similarity. The n_components parameter is the central part of this problem. It controls the dimensionality reduction in the Nystroem method. I want to understand how it affects the model. I'm using the Nystroem class from the Sklearn library in Python. Sklearn is a popular machine learning library. This class implements the Nystroem method, which I'll be using for kernel approximation. Increasing n_components doesn't always improve accuracy. It's a trade-off. A higher value can lead to better approximation but also overfitting, which reduces the model's ability to generalize to unseen data. This is incorrect. n_components refers to the number of eigenvectors used in the approximation, not the number of data points sampled. This is correct. n_components directly determines the dimensionality of the data after the Nystroem transformation, because it controls the number of eigenvectors used to create a lower dimensional approximation of the data. This is true. If n_components is almost as large as the number of samples, you're not reducing the dimensionality much, and that defeats the primary reason to use Nystroem, which is to reduce computation time. I see that we're working with a dataset containing 1,000 individual data points, each described by 50 different characteristics or features. This is important context for understanding the scale of the dimensionality reduction problem we're tackling with the Nystroem method. It's a pretty sizable dataset. I notice you are using a Gaussian kernel. This means the similarity between data points is measured using a Gaussian function, which depends on the distance between points in the feature space. This choice influences how the Nystroem method approximates the kernel matrix, but doesn't directly affect the number of components. It's just a piece of the puzzle, nothing to worry about for now. I want to be clear. This statement is false. While increasing the number of components in Nystroem generally leads to a better approximation of the kernel, it doesn't guarantee improved model accuracy. It's possible to overfit the model by using too many components. Think of it like adding too many ingredients to a cake. You might end up with a mess. This one is also false. The n_components parameter actually refers to the number of eigenvectors used in the approximation, not the number of samples. The number of samples used is controlled implicitly by the algorithm, depending on the implementation specifics. It's easy to confuse these two, but they are distinct concepts. This is true. The number of components directly sets the dimensionality of the transformed data. That's the whole point of using Nystroem, to reduce the number of features. Nystroem cleverly approximates the data while keeping the computation manageable. This is also correct. If you set the number of components close to the number of samples in your dataset, you're essentially not reducing the dimensionality. You're defeating the purpose of using Nystroem in the first place. Remember, the primary goal of Nystroem is to efficiently reduce dimensionality. This parameter in Sklearn's Nystroem class controls how many eigenvectors are used to approximate the kernel. Think of it like this. You have a giant puzzle, and Nystroem helps you solve it faster by using only a subset of the pieces to represent the whole picture. The n_components parameter determines how many of those key pieces you'll use. I have a dataset with 1,000 data points. Each data point has 50 features, which represent individual aspects of each point. Think of it as a table with 1,000 rows and 50 columns. The question is about understanding how the n_components parameter in the Nystroem method affects the performance and dimensionality of the machine learning model. It's a multiple-choice question testing your grasp of the algorithm's fundamentals. I'm using the Nystroem method to shrink my data, making it easier to work with. It's like taking a detailed map and creating a simpler sketch that still captures the important features. That's not always true. While more components usually give a better approximation, it's not a guarantee of better accuracy. Think of it like adding more detail to your sketch. Sometimes it's better, but sometimes it can add unnecessary complexity and confuse things. This is correct. The number of components directly sets the final dimension of my data. It's like choosing how many lines to use in my sketch. More lines mean more detail, but also more complexity. Absolutely. If I use almost as many components as I have data points, I'm not really reducing the dimension at all. That defeats the purpose of using Nystroem in the first place. It's like creating a sketch that is almost exactly as detailed as the original map. Not very helpful for simplifying things. Nope. N_components refers to the number of eigenvectors I use, not the number of data points. It's the number of principal components kept in the reduced dimensionality space. This parameter is how I control the level of detail in my sketch. A smaller value gives me a simpler, lower dimension sketch. A larger value gives a more complex sketch that more closely resembles my original map. I'm trying to understand how the Nystroem method works to approximate a kernel function and reduce the dimensionality of my data. I'm using a Gaussian kernel, a common choice for measuring similarity between data points. It calculates similarity based on a Gaussian distribution. I have 1,000 different data points, each described by 50 different characteristics. This parameter in scikit-learn's Nystroem class controls how many eigenvectors we use to approximate a kernel. Think of it as how much detail we keep when creating a simplified representation of the data. A higher value gives a more detailed, but computationally expensive, representation. We're dealing with a dataset containing 1,000 individual data points, each described by 50 characteristics or features. This is pretty standard. Nystroem helps us handle this sized dataset more efficiently. We use a Gaussian kernel to measure similarity between data points. It's a common choice because of its flexibility and interpretability. The kernel function calculates how close pairs of data points are. Nystroem approximates these distance calculations using only part of the full dataset. This statement is true. The value you choose for N_components directly sets the dimensionality of the resulting data after the Nystroem transformation. It's like choosing the resolution of a picture. A higher number means a more detailed but larger image. I agree, this is also true. If I set N_components to be very close to the actual number of samples, 1,000 in our case, we mostly defeat the purpose of Nystroem. Nystroem is supposed to reduce the computational work. The reduction in dimensionality would be too small to make a difference in computational time, negating the entire point of the method. I'm asking you to determine which statements correctly describe how the N_components parameter affects the Nystroem method used for dimensionality reduction. We'll explore what N_components actually does. I see that you are considering whether a larger N_components value always leads to better model accuracy. Not necessarily. While it often improves the kernel approximation, it can also cause overfitting, hurting the model's performance on unseen data. Think of it like this: adding more details doesn't always make a drawing better. This statement gets to the core of N_components. It directly determines the number of dimensions in the transformed data. A smaller N_components means a lower dimensional space. The parameter controls the number of dimensions that are preserved during the transformation. Let's analyze this. You're right. If N_components is almost the same as the number of samples, you aren't reducing dimensionality much, which defeats Nystroem's purpose. It's like trying to shrink a sweater that's already too small. I see that you are thinking N_components refers to the number of samples used in the approximation. Nope. It specifies the number of eigenvectors used, not the number of samples. The number of samples used is determined by the Nystroem method itself. I understand this section is about clarifying the role of N_components in the Nystroem transformation, a technique that approximates a kernel matrix for efficiency in machine learning. I know that you have a dataset with 1,000 samples and 50 features. This context is useful to understand how Nystroem might be applied to reduce the data's dimensionality. The Nystroem method approximates a kernel matrix, a core element in many kernel methods. It helps reduce computational cost. The goal is to reduce the number of features, thereby simplifying the model and potentially improving efficiency without significantly impacting accuracy. Nystroem helps achieve this.